So this is an ambiguous case of law of sines triangle. We are given 3 bits of information. Since I had alpha and A, I set up a law of sine problem. Since they told me B, I put B on bottom, that 22 on bottom, and I'm going to find sine of beta on top. Okay, there's my setup. My goal is to solve for beta. So I want to get beta by itself. How do I solve this problem? What do I need to do? I need to do what? We're going to cross multiply. So we're going to take the 2 things that we know and multiply them together. So 22 times sine of 72.2. That's going to be equal to the other one, 21 times sine of beta. So yesterday we got better at doing this quickly. But you multiply the 2 that you know and divide by the one you don't know. So I'm going to take 22 times sine of 72.2. I get that. And then what do I need to do with that? Not yet. No, not rounding at all. Divide it by 21 because I'm trying to get beta by itself. So we're going to divide by 21. So take that and divide by 21. I get that. 0.997, etc. Is that beta? That is not beta. I do not want to round it yet because it's not my answer. 4, 6, 8. Okay, and it goes on forever. Is going to be equal to what in this case? Sine of beta. It's not beta, it's what sine of beta is. I want to have just beta. What do I need to do in this problem to get just beta by itself? Inverse sine. I need to get rid of sine, so I'm going to do the inverse sine of both sides. Okay? So let me show you how to type this into your calculator. We do not want to round it, and use your calculator to make it easier. Okay? So what I want to do is I want to do second sine, and if you have a good calculator like me, you can see this better. I want that number right there plugged in, 0.997. Okay? If I want that number plugged in, I could technically type it in, but if I type it in by hand, I want to use every decimal. Okay? You can't round it. If you just put in 0.997, completely different answer than what I'm supposed to get. You need that whole number. Okay? Your calculator lets you do that. I'm going to hit, everybody look at me right now. Look to see how I'm doing this. I'm going to hit the second button, and I'm going to use this negative key down here. Okay? This negative key right here. I can't touch it. Negative key. We see right above that negative key how it says ANS? That's what I want. I want that answer that I just got. Instead of having to type that whole thing in, if I do second sine, so inverse sine, second negative key, it tells me ANS, the answer. Okay? Instead of having to retype that decimal, it does it for me. And then I hit enter. That's what beta is. Beta is equal to 85.9 degrees. It's an angle, so we go to 1 decimal. That is my beta for this problem. Make sense there? Okay? So I've got that solved. Cool. What else do I need to solve for? What would be Josh, you think gamma is the next easiest thing to solve for? Why is gamma going to be easy to solve for here? You know 2 angles. I know 72.2 degrees, and I know that I just found 85.9. So finding gamma is going to be pretty easy. All I need to do is subtract from 180. So 180 minus 72.2 minus 85.9. So in my calculator, 180 minus 72.2 minus 85.9. There's my answer. Gamma is 21.9 degrees. Okay, so I found beta, then I just found gamma right there. There's that answer. Did I solve for everything I needed to solve for? I still have to solve for C. So now that I know gamma, how should I solve for C? Do another proportion. We're going to do law of sines. We cannot use Pythagorean theorem. When do we use Pythagorean theorem? Right triangle. This is not a right triangle. None of my angles are 90 degrees. So I need to do a law sine problem again, just like we did originally. Okay, remember in the very beginning here, we set up a law sine using this proportion. We're going to use that proportion again. So sine of 72.2, that's alpha, over A, which was 21. Okay, that answer right there is going to be equal to, what are we solving for? C. So if we're solving for C, where does C go? Does C go on top or bottom? Bottom, it's a side. And on top, I'm going to write sine of 21.9, gamma. We're solving for C, so we're using its buddy, gamma. Okay? There it is. It's a proportion. How do I solve a proportion? Cross multiply. So again, we're doing this pretty quickly. Take the two that you know. So I'm going to take 21 times the sine of 21.9. And then do what with that? Divide by the one you don't know, sine of 72.2. It says, I take these two, I multiply those two together. I divide by the third one I don't know. Hit enter. I get 8.2265, etc. Do I need to do inverse sine of that? No. Why do I not need to do inverse sine? Yeah, it doesn't say sine. It just says it's all equal to C. I don't have to do inverse sine. That's my answer. C is equal to 8.23. If it said sine of beta or sine of alpha, if I'm solving for an angle, that's when I need to do that. In this case, I don't have to. Okay? That's fine. That's basically what we did yesterday. There's no difference there. This is an ambiguous case of law of sines. Let me show you what that means. Okay? So we're going to have to do a little bit more work here. We're not quite done yet. Okay? It's a long problem. I told you that yesterday. So this is what's represented so far. Okay? Look at what they gave us. A 72.2 degree angle. That's this angle right here. Okay? A side B is 22. So that's this side right here. And A is the side across from it, needs to be 21. So this side is 21. This is what we found so far. But notice what I'm going to do. So this side right here is 21. I'm not going to change its length. But what if I pivot it inside like that? Did this angle change right here? Did that side length of 22 change right there? And that 21 didn't change. The three things they told me are still exactly the same. But it gave me a completely different triangle. Okay? This is why it's called the ambiguous case of law of sines. This is one of your answers, the one we got so far. But there's a second answer. Okay? We need to solve for that second answer as well. Okay? It's a long problem, but again, I'm telling you, you got to be able to do it. So, anytime you are doing a law of sine problem, and when you did law of sine problem, you had to do inverse sine. Okay? Like this step right here. If you're doing law of sines and have to do inverse sine, you need to check for a second triangle. Okay, we're going to do a check for a second triangle. When we check for a second triangle, okay, the information they told you originally is still true. All of this information right here is still going to be true for my second triangle. That doesn't change. So I'm going to have alpha is 72.2. A is 21. And B is 22. None of those things changed. Okay? What we're going to do is looking at the first thing we solved. You're going to find whatever angle you found first. Okay? So which thing did we solve for where we had to do the inverse sine part? Beta. I solved for beta. I had to do inverse sine to solve for beta. Whatever angle you found, that's what you're going to use in your second triangle. Okay? And I'm going to use that angle to find its evil twin. Okay, that's a silly thing, but it helps me to figure out what's going on. I found beta first, so when I'm checking my second triangle, I'm going to find its evil twin, which in this case, I'm going to call beta 2. The second option for beta. Okay, I'm going to find beta 2. So when I find beta 2 here, okay, we're going to find its evil twin. So here's how we do that. It's really simple. To find the second option for beta, you're going to take 180 degrees minus whatever you found for that angle. So I found 85.9 for that angle, so that's what I'm going to subtract, 85.9. That will tell me my second option for beta. So in my calculator, I'm going to take 180 minus 85.9 and get 94.1 degrees. That is what beta 2 is. Okay? Once you have done that, you could care less about anything you found originally. So all of this work over here, I'm going to put my calculator on top of it so I don't even see it anymore, because it doesn't matter. I'm now going to solve this triangle just like we solved the first one. Okay? I've got this 3 bits of information up above still. Those things didn't change. I've got these 3 things right there. I just found beta 2. So what thing do you think I should solve for next? I already got B. B is 22. I already got that. Can I solve for C next? Yeah, let's find the angle for C. Let's find gamma 2. Okay? I already have 2 angles. They told me alpha. They told me beta. I can find the third angle. What am I going to do to solve for the third angle? 180 minus alpha, 72.2. Because these are the other 2 angles that we have in our triangle. Minus 894.1. That's going to find the third angle, always. If you have a triangle, all 3 angles are going to add up to 180. This is going to help me find gamma 2. So I'm going to take 180 minus, got to turn my calculator on, 180 minus 72.2 minus 94.1. Gamma 2 is 13.7 degrees. What else do I need to find? I need to find C. How am I going to, it's a side. How am I going to find C in this problem? Law of sines again, using that same setup we did before. Those numbers are still true. That 72.2 and that 21, that's still true. So we can still do law of sines. Sine of 72.2 over 21 equals, what am I solving for again? C2. I'm finding the second option for C. So what number is going to go on top? Sine of 13.7. It's a long problem. No one in here is going to tell you otherwise. It takes a while. The better you get at it, the faster it's going to go. But I need to solve this triangle now. Okay, so I've got this proportion over here. So, Karan, what am I going to do to solve that proportion now? Cross multiply. So what am I going to type into my calculator? 21 times sine. Yep, he took the 2 things that he knew. He took 21 times sine of 13.7. And then what else do you need to do? Divide by the missing thing. So divide by sine of 72.2. 5.22. Do I need to do inverse sine here? No, because it's just equal to C2. It's not sine of C2. So C2 is 5.22. Long problem. It takes a long time, but it's worth a lot of points. Let me explain one more time what we did. Okay? We set up the problem. It was an angle side side problem. Oh, that's naughty. Angle side side. Okay? So I knew I was going to check for a second triangle eventually. Okay? I solved for the angle. When I did inverse sine, that again gives me that clue. I found my second angle on my side. Once I've done that, I check for my angle. Whatever angle I found first, in this case it was that 85.9, I'm going to do its evil twin. So to find its evil twin, we take 180 minus the angle we found, and then got that beta 2, and then just solved it like normal. We found gamma 2 and C2.